Hello.
Hello, sir.
Yeah. Can you hear me?
Yes, sir.
Okay. So we'll continue with where we stopped last class. We had discussed GIF and fractional part functions. The next special function is the signum function. Basically, it is defined like this: f of x is equal to x by mod x. So it will basically be 1 if x is greater than 0. It was defined as 0 if x is equal to 0 and -1 if x is less than 0. So this is the type of function where you cannot directly put 0 in the input here, but the function is specially defined. Basically, 0 is not in the domain of the function, right?
Yes.
So this is a special definition. At 0, function is defined to be 0. That is not
Mm.
part of this. This just gives us this part and this part, right?
Yes.
So what you can say here is that the function is x by mod of x for every x other than 0. And it is 0 at x is equal to 0, right?
Mm. Yes.
For every x other than 0, the function values will be 1 and -1. For positive x, it will be 1. For negative x, it will be -1 because your mod x will become x or minus x, right?
Yes.
So that is your signum function, and sometimes it is written as SGN of x. That basically means x by GIF of x, x by modulus of x. So this is a symbol for the function. The domain of the function is all real numbers because we have included the 0 here in the definition.
Mm.
And the range of the function is just 3 elements. One, this is the range, right?
Yes.
Obviously, it is a many to one function.
Mm.
Okay, so that
Mm.
is your signum function. Then we have something known as the identity function. Identity function. Basically, the identity function is the function f of x equals x. This is called the identity function. And that means that domain will be x belongs to real and range is also going to be x belongs to real, right?
Yes.
All real numbers is the range, all real numbers is the domain, and the input is equal to the output. So this is a
Mm.
simple function. You just need to know the name that this identity function is f of x equals x.
Okay.
Then the
Yes.
idea is for composite functions. This is important to understand. So basically, sometimes it is not like you have just a single function operating on the input. You could have multiple functions which connect the input to the output. So, for example, if there is a function f from set A to set B, and now there is a function g from set B to set C. This notation, you should understand what this means. This notation says that f is a function from A to B. A is the domain, B is the codomain, right?
Yes.
And
Yes.
G is a function from B to C, where B is the domain and C is the codomain.
Yes.
Then the composite function GOF, which can also be written as G of f of x. This is the way to write the composite function, and this composite function would be from A to C. Why is it from A to C? Because first you have f of x, which takes inputs from A and gives outputs in B. And
Mm.
then that output that is in set B is given as input to the G function. So
Yeah.
the B function values are given as input to the G function, and the G function will take it to C finally, right?
Yes.
Because G is from B to C. So
Mm.
finally, you are giving inputs X as A and you are getting outputs C as Y, right?
Yes.
So basically the overall function g of f is from a to c, right?
Yes.
So we can say g o f of a is going to be g of f of a. That's the meaning. Now, what is happening here is the input is given to the f function. So this is my f function. It gives output of f of a. Inputs were coming from basically the A set. This was the output set, which is B set. And this output f of a is sent to basically the function g, which gives out your g of f of a, right? And
Yes.
this will belong to the C set.
Mm.
There are two consecutive functions that are applied on the same input, and that is the meaning, right?
Mm. Yes.
It is obvious that GOF of A does not have to be equal to FOG of A. This means f of g of A. This means g of f of A. You can
Mm.
easily see by taking some simple examples. For example, g of x, let's say, is x squared, and f of x is x plus 1. We can easily see that g of f of x is going to be what? G of f of x is x plus 1, and g of
Yes.
x plus 1 will be x plus 1 square. Whereas f of
Yes.
g of x is going to be f of g of x is x square, and f of x square is x square plus 1. So
Mm.
it is not necessary that when you do composition of g of f of x and f of g of x, they will be same.
Yes.
In some special cases, it could happen that it is same, but that is rare. Usually it
Yes.
won't happen,
Yes.
right?
Yes.
When you think about the domain of a composite function, you have to think about, let's say, g of f. So basically that means g of f of x. When you try to think of the domain of the composite function, it is not enough for x to be in the domain of f.
Mm.
First condition is x should belong to domain of f. But that is not enough because the output of f is being given as input to g, right?
Yes. Yes.
So what you should have is range of the f function should belong to the domain of g. Do you understand what I'm saying?
Yes, sir.
Unless both the conditions are true, the function will not be defined. The domain of the overall composite function is basically all x such that x lies in the domain of f, and also the range of the f is in the domain of the g.
Yes.
Similarly, when you talk about the range of GOF function, you have to think about, first of all elements x in domain of GOF, right?
Yes.
And then you have to think of the outputs of the overall function when you give those elements x. So
Yes.
these two conditions have to be anyway checked because domain of GOF you need to know to predict the range.
Yes.
After that, you have to figure out what will be the range of f of x. What is first of all range of f of x, and from there, what is the range of g of f of x?
Yes.
So you have to think of all of those things, then only you'll be able to correctly figure out the range.
Okay.
Are you understanding what I'm saying?
Yes, sir.
Then we talk about the idea of equality of functions. When can we say that two functions are equal? Equality of functions basically has three conditions. F and g are said to be equal. First of all, if domain of f is the same as domain of G. So it should not be that the domain is different for different functions. Then they cannot say that they are equal. For
Okay.
example, f of x is equal to x plus 2 and g of x is equal to x square minus 4 by x minus 2.
Hmm.
They are not equal functions because 2 is not in the domain of G,
Yes.
but 2 is in the domain of G.
Yes.
Even though when you cancel it out, this is going to give the same values of x plus 2 at all values of x other than 2.
Hmm.
Any normal value of x, if you take not 2, you will get same answer, right?
Yes.
Two functions look like they are equal, but they are not going to be called equal because
Yeah.
actually the domain of the functions is different.
Yes.
Here the domain is all real numbers. Here the domain is all real numbers minus 2.
Hmm.
The second condition is the obvious condition. Two functions are going to be equal. Obviously, f of x should be equal to g of x for all x belonging to the domain, right?
Yes.
F of x is equal to g of x for all x belonging to the domain of f and g. So this is an obvious condition. Otherwise, there is no chance that they're equal. But this is also something that you have to check.
Yes. Yes.
Okay. Then one or two theorems that you should know. First theorem, this concerns your composite functions. So this is if there is a f from A to B, a g from B to C, these are functions, and similarly an h from C to D. These are three functions. Then we can say that H composition with GOF is the same thing as H composition with G and then composition with F. So basically, this is like the associative property.
Hmm.
So you can put the bracket here and find the overall composition, or you could put the bracket here and find the overall composition as long as you don't change the order.
Okay.
You cannot say that HOGOF is same as HOFOG. That's wrong.
Yes.
As long as the order is same, the bracket positioning doesn't matter. Okay.
Okay. Yes.
You can take any three functions and check whether this is correct or not. Take any three random functions and see what is coming for HOGOF and what is coming for HOG composition with F.
Yes.
Okay. Then the next idea is theorem 2, which says if f is a function from A to B, then f composition with the identity function is the same as I composition with the identity A and I composition B with the f function, where which is the same as f, where IA and IB are identity functions on A and B respectively. Are identity functions on A and B respectively. So what do I mean when I say identity functions on a set? Identity function we have seen is the function f of x equals x.
Yes.
So when I say IA, I mean f of x equals to x for inputs from A.
Hmm.
And when I say IB, that means f of x equals to x, but the inputs are from the B set,
Okay.
right?
Yes.
Now, what we are saying here is that if you take a function and do composition of that function with the identity set, you will get back the same function, right?
Okay. Yes.
Why? Because it is going to be f of IA of x, right? But
Yes.
IA of x will always be f of x,
F of x.
which can be written as basically f, that is directly f as you have proved, or you can write this as f of IB of x, because IB of x is also x, right?
Yes.
So you can write this as this also, correct?
Yes.
So basically, this is what? This is IB of f of x.
Equal to x.
So that is going to be same as f of x.
Yes.
So what we are saying is that the identity function ensures that composition of any function with the identity function is going to be the same function.
Yes.
Are you understanding?
Yes, sir.
Then there is even and odd functions. Even and odd functions. So this is very important. So pay attention. A function
Yeah.
f from a to b is even if f of minus x is equal to f of x for all x belongs to a. Right? So any
Huh.
element x in the domain, you can always write f of minus x is equal to f of x, then the function is even.
Yes.
So f of minus x equals to x means if you try to draw the graph of the function, whatever happens on this side, let's say this is x, this is my f of x. So point is x comma f of x, right? Now
Yes.
equidistant from this side, there is a point minus x. Now f of minus x is equal to f of x means that value is also somewhere here, right?
Yes.
That happens for all x, which means this is a reflection on the y-axis, right?
Yes.
Y-axis will be your mirror and the graph of an even function will be symmetric about the y-axis.
Yes.
Do you understand what I'm saying?
Yes, sir.
Similarly, f from a to b is called odd if f of minus x is equal to negative of f of x for all x belongs to a. So if it is odd function, the value of the function is going to be lower or negative sign, opposite sign. So it will be somewhat like this, right?
Hmm.
If this was the point where f of x and x comma f of x was this point, what we are getting is negative x comma f of minus x. And f of minus x is equal to negative f of x,
Yes.
right?
Yes.
Because of the property here, f of minus x is negative f of x. So we can see that it's a reflection again, but this time it is a reflection
About x.
about the origin, not x-axis.
Hmm.
If I had done about x-axis, I would have drawn like this.
Hmm.
Do you understand what I'm saying?
Yes, sir.
This is like everything positive side, and we are getting the same type of things, but in the opposite direction.
Hmm.
This is the reflection of this curve across the origin.
Okay.
Is it clear?
Yes, sir.
So this odd and even functions are very important. Examples of trigonometric functions which are even are cos. Cos function is even. Then obviously sec function will be even and so on.
Yes.
Similarly, sine function and tan functions are odd. Is it clear?
Yes, sir.
Now, one important thing to remember about even and odd functions is that any function f can be written as the sum of an even and an odd function. So what do we mean by that? So think about it. F of x, if I write as f of x plus g of x by 2, okay, instead of that, I can write it like this. F of x plus f of minus x by 2 plus f of x minus f of minus x by 2. Notice that
Yes.
this is the same thing as f of x, right?
Yes.
Now, which one of this is even and which one is odd?
Sir, f of x plus f of minus x by 2 will be even.
Right. So this is the even part and this is the odd part. This
Yes.
is even because even if you replace x with minus x, it's the same thing.
Yes.
But here, if you replace x with minus x, it becomes negative of the originals. So this is
Yes.
odd. So we are able to say that f of x is equal to this is the way to break down a function into even plus odd parts.
Yes.
I hope you are understanding.
Yes, sir.
Okay. Then there is another thing that sometimes you might see f of x is equal to max of g of x and h of x. You could also see a function where they are written min of g of x and h of x.
Yes.
So what that means is you draw the graph of f of x. Let's say this is the graph of f of x, and let's say the graph of g of x is like this.
Mm.
Do you understand what I have drawn?
Yes, sir.
So what we can see here is that till here, which graph is lower? It is f of x that is lower, no, till this point before that.
Yes.
F of x is lesser than g of x, but g of x is bigger than f of x here.
Mm.
Okay. So then what we want to say is in this part before a, your maximum is f of x, g of x is maximum. Between
Yeah.
a and b, this point, let's say, is b, the maximum is f of x, right?
Yes.
Here it was g of x, here it was f of x. And then again, this goes down like this, and g of x is rising much faster. So after
Mm.
b, the maximum is g of x again.
Yes.
Now, we can write it like this also. F of x is equal to g of x for x less than a. F of x is f of x for x belonging to a to b. And it is g of x for x greater than a.
Yes.
Do you understand what I'm saying?
Yes, sir.
Another way to think about this max function, and this is important from the point of view of problems. If I have a situation like this, I can also write it like this: g of x plus h of x by 2 plus mod of g of x minus h of x by 2. Now, why is this mod going to give us the correct answer?
Mm.
So think about it. If g of x is greater than h of x, the mod will open with a positive sign.
Yes.
In that case, when it opens with a positive sign, hx by 2 gets cancelled and you end up with g of x, right?
Yes.
So if g of x is bigger than h of x, f of x becomes simply g of x,
Yes.
which is what should have happened, no, from here.
Yes.
Similarly, if g of x is less than h of x, notice that it will open with a negative sign and the maximum will come as h of x in that case.
Yes.
Do you understand what I'm saying?
Yes, sir.
Max g of x and h of x will come out as h of x in that case, which is what we
Hmm.
wanted it to come also,
Okay.
right?
Yes.
This is a good way to define the max function because now we don't have to draw the graph. We can just write this, right?
Yes.
The min function, I think, can be defined with a minus sign,
Yes.
like this with a minus sign, g of x minus h of x by 2.
Hmm.
Okay, so that is your max and min functions. Now, how much have you worked? Have you started doing your Allen book?
Yes, sir. I have done that many one into functions question.
I don't have the book. You
And
have to tell me how much you have done. Beginner boxes, how much have you done?
yes, sir. Sir, I have done DY 1, 2, and 3, sir.
Is there any doubt there?
No, sir. In that there is no doubt. But sir, at means after some device, there is DY 11 where into and one functions question are there.
Mhm.
So I solved them. So I have one question for doubt.
Send it on WhatsApp.
Yes, sir. Right, sense.
Okay, so question is f of x is given as x squared plus 3x plus a by x squared plus x plus 1. F is from R to R. Find the value of a so that the given function is 1, 1. F of x is 1, 1. Okay, so there are other ways to solve the problem here, which involve a little bit of knowledge of calculus and differentiation, but we will not do it like that. We will use the basic definition of 1, 1, right?
Yes. Yes.
So basic definition of 1, 1 is if f of x1 is equal to f of x2, it should imply x1 equals x2, right?
Yes. Yes.
So from here, let's try to write this condition and assume that it is 1, 1. So we'll write the condition. We'll say x1 square plus 3x1 plus a by x1 square plus x1 plus 1 is equal to x2 square plus 3x2 plus a by x2 square plus x2 plus 1, right?
Yes.
From here, we should somehow be able to prove that x1 equals x2, right?
Hmm. Yes.
If we get that guaranteed, then it is 1, 1, right?
Yes.
So let's simplify it. Cross multiply x1 square, x2 square plus 3x1, x2 plus a. Wait 1 second. Cross multiplication I'm doing with x2 square. So I'll get 3x1 x2 square plus a x2 square plus x2 x1 square plus 3x2 x1 plus a x2 plus x1 square plus 3x1 plus a, right?
Yes.
On the other side, I will get also x1 square x2 square plus 3x2 x1 square plus a x1 square plus x2 square x1 plus 3x2 x1 plus a x1 plus 1. So x2 square plus 3x2 plus a, right?
Yes.
Now notice that many terms will get cancelled, like this term and this term. Then we're getting cancellation here and here. And any other cancellation? No, right?
A, sir, A.
A is getting cancelled. And now we'll take everything to one side and try to take factors, okay?
Yes.
So basically this and this you can take factors. 3x1, x2. We will get x2 minus x1, right?
Yes.
Plus a, x2 square minus x1 square, right? So this and
Yes.
this is done, this and this is done. Plus x1, x2, x1 minus x2. This and this is done, right? Then
Yes.
plus a, x2 minus x1, right? Then
Yes.
you have plus x1 square minus x2 square plus
Equal
3
to
times x1 minus x2 equals 0, right?
yes.
Okay, so now I will take x1 minus x2 or x2 minus x1, whichever one, outside and try to see what is coming inside that bracket, right?
Yes.
So let's do that. We are going to get x1 minus x2, I'm taking common outside, and I'm getting from here minus 3x1 x2, right?
Yes.
Plus a times x plus minus a times
Minus.
x1 plus x2.
Yes.
Then we are getting plus x1 x2, then
Yes.
minus a plus x1 plus x2 and
Yes.
plus 3, right?
Yes.
Okay, so now here what we have to do is think of what we are getting inside. This part should never be 0, right?
Yes.
If this is should never be 0, then only we can say guaranteed that this must be true, right?
Yes.
Are you understanding what I'm saying?
Yes, sir.
So let's analyze this part. We are getting simplification a little bit we can do. So we are getting this common between this and this. You will get x1 plus x2, 1 minus a, right?
Yes.
Correct? And
Yes.
minus 2x1, x2 and plus 3 minus a, right?
Yes.
Okay.
Yes.
So from here we are getting, let's solve for a because that is what we want. Let's check the
Yes.
condition that this is equal to 0, and
Okay.
that should be impossible. This should never be equal to 0 technically, right?
Hmm.
Do you understand what I'm saying?
Yes, sir.
So I will solve for a and I will get x1 plus x2 minus 2x1 x2 plus 3 should not be equal to a common 1 plus x1 plus x2, right?
Yes.
So a should not be equal to x1 plus x2 minus 2x1 x2 plus 3 by 1 plus x1 plus x2, right?
Yes.
And notice that this can be split as a should not be equal to, this can be written as 1 plus 2. This is 1 plus 2, right? So 1 plus
Yes.
x1 plus x2 can be cancelled. You get 1 minus 2 x1, 1 plus 1 plus 2 minus 2 x1 x2 by 1 plus x1 plus x2, right?
Yes.
We are getting that a should never be equal to this value. Now,
Hmm.
uh, there should never be 0, 1 plus this value. We have to, for any values of x1 and x2, what is the possible values of this? Uh, find the value of a so that f of x is 1, 1. This should imply x1 is equal to this. This should never be 0. So how can we make sure that this is never 0?
Hmm.
Uh, maybe 1 minus a. If it is equal to 0, I will get a is equal to this. That should be impossible. So, hmm. See, there is an easier way out of it, but I didn't want to use that. The easier way is the derivative should be positive or negative. It should be a monotonically increasing function or decreasing
Okay.
function.
Hmm.
See, if it's an increasing or decreasing function, it will never be coming down. No, it can never repeat.
Yes.
So the normal way to do it is f dash x check f dash x, right?
Yes.
If you check f dash x, it should be either completely positive always or completely negative always.
Yes.
Right now, by doing the basic definition, we are not getting something nice because x1 and x2 are random values.
Sir, I done by that differentiation method, so I am getting that minus 2x square plus 2x
Hmm.
multiplied by
Hmm.
1 minus a plus
Differentiation
3
method
minus.
only you should do, I think, because the normal the basic definition method is not coming very nice.
Yes.
1 second. So if I take the f dash x, it will be derivative of the numerator is 2x plus 3 times x square plus x plus 1 minus derivative of denominator is 2x plus 1 times x square plus 3x plus a divided by x square plus x plus 1 whole square, right?
Yes, sir.
So, okay, so let's simplify this a little bit. We can write it as 2x. Okay, we can just do it. So 2x cube plus 2x square plus 2x plus 3x square plus 3x plus 1 minus 2x
2x cube.
cube plus 6x square plus 2ax plus x square plus 3x plus a, right?
Yes.
So 2x cube gets cancelled. You have 5x square here and 7x square here, right? So
Yes.
minus 2x square. So this is gone, this is gone, this is gone, and this is gone. 5x here and minus 3x. So plus 2x minus this. Plus
Hmm.
2x minus 2ax, right?
Yes.
And then you have plus 1 minus a, right? Correct.
Sir, it should be sir plus 3 minus a.
Plus 3 minus a it should be, right? Plus
Yes.
3 minus a. So we are getting this is my derivative minus 2x square plus x common 2 minus 2a plus 3 minus a divided by x square plus x plus 1 whole square, right?
Yes.
Now what we have to ensure is that the derivative is always having a single sign, positive or negative always, right? If the derivative is either positive or negative always, what can you make sure then? That
The
it
graph.
doesn't change the behavior, right? Function.
Yes.
If it is increasing, it is always increasing. If it is decreasing, it is always decreasing. If it changes its behavior, then it will have multiple points which are equal, right?
Yes.
So in order to do that, you should realize that this is always positive, right?
Yes.
So now we just have to figure out which sign this will be always. It cannot be
Mm.
always positive because their first term is negative, right? Quadratic.
Yes.
The only possibility is when the first term of the quadratic is negative, the graphs are going to be like this, or like this,
Mm.
right?
Yes.
We want to take this cannot happen because here the derivative will become positive sometimes. This
Yes.
can happen or this can happen, right?
Yes.
Correct. But this also we should not take because there the derivative will be zero somewhere, right?
Mm.
So we should take this
Discriminant
case where
will be negative.
discriminant is less than zero, right?
Yes.
So discriminant is less than zero will give us the condition. So 2 minus 2a whole square minus 4 into minus 2. So plus 8 into 3 minus a is less than zero, right?
Yes.
So you're getting 4 plus 4a square minus 8a plus 24 minus 8a is less than 0. You're getting 4a square minus 16a plus 28 is less than 0. Cancel 4. A square minus 4a plus 7 is less than 0, right?
Yes.
So now if you think about it, this is a minus 2 whole square plus 3
Mm.
is less than 0 is not possible only, right?
Okay. Yes.
It is always greater than 0, right?
Yes.
Which means the graph is of this form then, right?
Mm. Yes.
Which means the x should we should only restrict ourselves to a particular region, right?
Yes.
Where it has the same sign, right?
Yes.
Do you understand what I'm saying?
Yes, sir.
So between the roots, you can say your x should be between the roots and all, right?
Mm. Yes.
Where x, so that the given function
Mm.
is 1 to 1. Fx is real, so I think there is some mistake because
Sir, they
fx,
were asking
huh?
the parameter for a to be 1 1.
So we
Yeah,
are
that will
not
be no, no, sir.
getting anything, no, because for all x you cannot have the it positive, no.
Yes.
Your x has to be restricted for it to be 1 1, right?
Mm. Yes.
Like the condition that you're getting on discriminant is impossible.
Yes.
If it was some nicer condition, then we would have gotten the range of a, right? Do you understand what I'm saying?
Yes, sir.
This doesn't, this is a minus 2 whole square plus 3. So
Mm.
how can it be less than 0?
Yes.
Maybe there is some mistake in the question, doesn't matter. But
Sir, answer is given like the function is not monotonic, so no value of a is possible.
so that is what we are getting,
Yes.
right?
Yes.
Okay, so you have to solve a few more questions. Then next class we will be discussing questions only. The theory, basic theory is done. We need to do some questions and understand some more things through problems. Okay,
Yes, sir. Yes, sir.
so keep trying the do-it-yourself exercises. Keep doing the questions. We will also discuss more questions in the next class.
Yes, sir.
So just work on the problems for the chapter right now.
Yes.
Okay, next class will be on Friday.
Okay.
Friday, same time. Basically, we can fix the classes at Sunday, Tuesday, Friday.
Okay, sir.
So that is the schedule we can follow, and just try the Allen module questions. Okay.
Yes. Yes, sir.
Okay. That's all for now. I'll see you next class then.
Thank you, sir.